Okay. Let's see. The angle, we're talking about dihedral angles. The angle between two planes is called a dihedral angle. Auxiliary views often need to be drawn to show dihedral angles' true size, mainly for dimensioning purposes. So in A, you have basically a basic front view and top view with all the lines going through it at a 90-degree angle from the front view, so there's no problem. So that surface A and B are true length and true size, okay? But when you get angles in there, and like they do in B, you're going to have to do some projecting lines up. So in the front view, those angles are not going to be true size and shape. So you're going to have to draw an auxiliary view C over in the right C. You're going to have to get that true angle, okay, you're going to have to project down from that top view. Okay, we're moving into something else called developments and intersections. Development is a flat representation or pattern that, when folded together, creates a 3D object. So there are a lot of things in the world that are folded or bent, like this case, and they actually make them flat. And they got a machine, I think it's called a bender, that they put the part in and they bend it at the precise angle and at the precise location. And when you're drawing in CAD or drafting back in the old days, you had to remember that, because if you look over on the right hand side where it says bend up 90 degrees at 3/8 inside bend radius. So when you got that bend radius, you're going to have to, one of the things you need to look for is to additional material to allow for that bend radius. So that's just one of the things to look out for. Developments. A developable surface may be unfolded or unrolled to lie flat. Surfaces composed of single curved surfaces of planes or a combination of these types are developable. Like paper bags, okay? You have paper bags, they're usually cut in a certain way and then they're folded up to form that bag. You have three shapes, or four shapes rather: prism, cylinder, pyramid, and cone. For engineering purposes, this is probably the big use for this is in HVAC, heating, ventilating, and air conditioning, where you have duct work. If you look up in the ceiling, if you are able to look up in the ceiling, take back the ceiling tiles and look up in that area up there, you would see duct work. And most of that duct work is constructed using this technique right here. This is packaging. It's a root beer carton. Probably either 12-pack or 24-pack of root beer, canned root beer. This thing's laid out just like a paper bag, only it's cardboard, and they fold it to create a box. The development of a surface is that surface laid out on a plane. Practical applications of developments occur, like I said, in sheet metal work, stone cutting, pattern making, packaging, and packaging design. Developing a plane or an oblique cylinder. The development of a intersection of a plane and oblique cylinder is similar to that for a plane and oblique prism. Okay, in this case, you're going to need to know something about ellipses, how to lay out ellipses. Lay out this shape right here, so when you fold it up, for example, on the right hand side, you're going to have a cylinder, and it's going to have a lid and a bottom to it. So there's a way of doing that, and it takes a lot of patience, a lot of fun. It could be fun to make, but it's going to take a lot of patience. Hems and joints for sheet metal and other materials. Hems are used to eliminate the raw edge as well as to stiffen the material. Okay, and again, this is used a lot in sheet metal where you have seams where you create, when you're putting your ductwork together, you got to have a seam there to hold it together so you won't get any leaks. You must add material for hems and joints to the layout and development. Just like that bend radius I was telling you about earlier, you got to add material for, extra material for that bend. The amount you add depends on the thickness of the material and the production equipment. Transition pieces. Also in ductwork, you're going to have transition pieces from rectangular duct to round duct, or larger rectangular duct to smaller rectangular duct. You've got to get it in and around beams and pipes and different things in that ceiling area. So this is what they're talking about in transition pieces. Transition piece is one that connects two different shaped, different sized, or skewed position openings. In most cases, transition pieces are composed of plane surfaces and conical surfaces. So over on the right hand side, lower right, you got ductwork parts. Those are HVAC parts for ductwork. Triangulation. Triangulation is a simple method of dividing a surface into a number of triangles and transferring them to the development. To find the development of an oblique cone by triangulation, divide the base of the cone in the top view onto any number of equal parts and draw an element at each division point. Looks like fun, though. Spheres. Excuse me. If you're developing a sphere, the surface of the sphere is a double curved and is not developable, but it may be developed approximately by dividing it into a series of zones and substituting a portion of a right circular cone for each zone. This looks like a lot of the maps or world maps that you see drawn in books and other publications. Axis of revolution. Revolution, like auxiliary views, projection, is a method of determining the true length and true size of an incline and oblique lines and planes. The axis of revolution appears as a point in this view. The object revolves but does not change shape in this view. It is the adjacent view in which the axis of revolution, if it were drawn, would show as a line in true length. The dimensions of the object that are parallel to the axis of revolution do not change. That sounds exciting, don't it? So we're trying to draw surface. In the top view, you got A, line A. In the front view, actually it would be the auxiliary view, A, line A, and then on the right hand side you have surface A. So in this case, your axis, your revolution, would be 30 degrees. And if you were doing this auxiliary views in 3D CAD, 3D CAD can be used to generate any view in one or two steps, eliminating the need to project auxiliary views and revolve views manually. So one of the really nice things about the 3D CAD programs like Inventor and SolidWorks is I can, when I go to set my drawing up, draw my standard orthographic projection views, my front view there on, and then my right hand side view, and then a top view at the top. It's just a matter of clicking. I can, from my part drawing, I can pull in that front view, and from the front view, I can pull to the right, get the right view. I can pull it up to the top and get the top view. And if I tell it to, I can tell it to draw an auxiliary view to the upper right of the front view. It's very easy to do in 3D CAD. And that's it. Hope y'all, this is a little bit longer than the rest of them. So hopefully this helps when you're doing your quiz. So have a good day.